Hi, in this video I am going to show you another example of the application of differential equation in electrical circuits. Let's say we have a problem like that. We have a circuit with an inductance, resistance, and capacitance in it, and our total voltage is 24 sine of 10t, and here we want to find the charge in that circuit and the current in a circuit when the initial value of our charge and current is equal to 0. So we have an electrical circuit again with inductance, resistance, and capacitance, and our total voltage is E, and we have a current that is going in that circuit. So we have our inductance, resistance, and capacitance. So if you look at my first video on this subject, you can see that we came up with the general formula in the form of L d2q dt squared plus R dq dt plus 1 over C Q is equal to our total voltage. So this is the general formula for a circuit with inductance, resistance, and capacitance. The total voltage is equal to the summation of the voltages in inductance, resistance, and capacitance. And now in our case, our L is 1, R is 12, and C is 0.01, and our total voltage is 24 sine of 10t, and we need to find the charge and the current. So let's go ahead and plug those values in this equation. We're going to have d2q dt squared plus our R is 12, dq dt plus 1 over C. 1 over C is 1 over 0.01 is equal to 100. 100 cubed is equal to 24 sine of 10t. Now we have a second order non-homogeneous differential equation, and in order to solve this, we know that the general solution for a differential equation like that can be written as the solution to the corresponding homogeneous portion of this equation plus the particular solution to the non-homogeneous portion. So in order for us to solve for the corresponding homogeneous portion, we can use the auxiliary polynomial and write this portion as m squared plus 12m plus 100 is equal to 0. So here we can find the value for the m, or m1 and m2 will be equal to minus b minus 12 plus or minus the square root of b squared, which is 144, minus 4ac minus 400 divided by 2a divided by 2. So this is equal to minus 12 plus or minus the square root of minus 256 divided by 2. So this is equal to minus 12 plus or minus the square root of minus 16 squared divided by 2. So that is equal to minus 2 plus minus 12, sorry. Minus 12 plus or minus 16 I divided by 2. So the answer will be minus 6 plus or minus 8i. So we know that the general solution for an answer like that will be our QC will be equal to e to power minus 6t multiplied by a constant c1 times sine of at plus c2 cosine of at. So this is the solution to the corresponding homogeneous portion of this equation. Now to find the particular solution for non-homogeneous part, as we see our non-homogeneous portion is 24 sine of 10t. So if we get a derivative of that, we are going to have a cosine of 10t, and if we take a second derivative, again we are going to have sine of 10t. So we always will have sine of 10t and cosine of 10t. So we have to assume a solution as a constant times sine of 10t. Let's assume a solution plus b cosine of 10t. So if that is, if we assume that is our solution, so dq over dt, if we take the derivative of that, we are going to have 10a sine of 10a, sorry, the derivative of sine is cosine of 10t. Then the derivative of cosine is minus sine, so minus 10b sine of 10t. And our second derivative will be derivative of cosine is minus sine, so minus 10 times 10 is 100a minus 100a sine of 10t, and minus 100b cosine of 10t. So if we assume our solution to the non-homogeneous portion is like this, so our first derivative will be that, and our second derivative will be this. So let's go ahead and plug the value of q, dq dt, and d square q t square in this equation. So if we do that, so we know our general solution. Our general solution q is qc plus qp, and this is our qc. Now we are trying to find the qp. So if we put those values in here, d2 squared dt is minus 100a sine of 10t minus 100b cosine of 10t plus 12 multiplied by dq dt. So 12 multiplied by that will be plus 120a cosine of 10t minus 120b sine of 10t plus 100 multiplied by q. So 100 multiplied by q plus 100a sine of 10t plus 100b cosine of 10t . 100 multiplied by this is equal to 24 sine of 10t. So here if we take Let me write this QC right here again. Our QC is e to power minus 6t times C1 sine of AT plus C2 cosine of AT. Now let's go ahead and factor out the sine of 10t. So if we factor out sine of 10t, you are going to have sine of 10t multiplied by minus 100a minus 120b plus 100a and let's go ahead and factor out the cosine of 10t plus cosine of 10t multiplied by minus 100b plus 120a and plus 100b is equal to 24 sine of 10t. Now, if we compare both sides of this equation, we can simplify this. This 100 and that will cancel out, and this will cancel out. So if we compare both sides of equation, on right side we have 24 sine of 10t, and here the coefficient of sine of 10t is minus 120. So minus 120b. So that means the coefficient minus 120b must be equal to 24. So our b will be equal to minus 24 divided by 120. Or this is equal to minus 2 divided by 10, or is equal to minus 1 divided by 5. So our b is minus 1 divided by 5. So our b is minus 1 divided by 5. And again, on this equation, we do not have any cosine of t on the other side of the equation. So the coefficient of the cosine of t is equal to 0. So 120a must be equal to 0. So a will be equal to 0. So our a will be equal to 0. So we had assumed a particular solution in that form. So our particular solution for the non-homogeneous portion will be a, which is 0. So this will a is 0 plus b. B is minus 1/5 cosine of 10t. So that's minus 1/5 cosine of 10t. So this is the solution. This is our particular solution for the non-homogeneous part. So we said that our general solution was in a form, for that differential equation, was in the form of QC plus QP. And we found QC, which QC is e to power minus 6t multiplied by C1 sine of AT plus C2 cosine of AT plus QP, which QP is minus 1/5 cosine of 10t. So this is our solution for our differential equation. Now the conditions that we have a condition that our charge when time is equal to 0 is equal to 0. So if time is equal to 0, that means our charge when time is equal to 0 will be equal to e to power 0, which is 1, multiplied by, if time is 0, this will be sine of 0, so sine of 0 is 0, plus, if time is 0, this is cosine of 0. The cosine of 0 will be 1, so plus C2 minus, if time is 0, this is cosine of 0. Cosine of 0 is 1 again, so will be minus 1 over 5 is equal to 0. So the condition we had, our charge when time is 0 is equal to 0. So our charge when time is 0 will be that. So that means C2 will be equal to C2. That means C2 minus 1 over 5 is equal to 0, so C2 is equal to 1 over 5. So we find the value for C2. Now, in order, let me write that value C2 is equal to 1 over 5. And to find the current, we know that the current by definition is the rate of change in charge with respect to time. So the current is equal to the derivative of Q with respect to time. So in order for us to get the derivative of the first portion, we have to use this formula. The derivative of AB with respect to time is equal to A multiplied by the derivative of B with respect to time plus B multiplied by the derivative of A with respect to time. So if we use that formula, the derivative, the first, which is e to power minus 6t, multiplied by the derivative of this. Derivative of this will be 8 C1 cosine of 8t, and derivative of that is minus 8 C2 sine of 8t then plus the derivative of the first portion, which is minus 6 e to power minus 6t multiplied by the first portion, multiplied by C1 sine of 8t plus C2 cosine of 8t. Then minus derivative of that. Derivative of cosine 10t is minus 10t. It is minus sine, so minus and minus will become plus. So will be plus 10 divided by 5 sine of 10t. So 10 divided by 5 is 2. Now, in here, if we apply the condition, initial condition, our current when time is 0 is equal to 0. So our current, so this is our current. So our current at time 0 will be equal to 0. So let's see. When time is 0, we have e to power 0, which is 1, multiply 1. At time 0, we are going to have the cosine of 0, which is going to be 1. So we are going to have 8c1 multiplied by 1. At time 0, this will be sine of 0. So sine of 0 will be 0 plus at time 0, e to power 0 will be 1, so we have minus 6 multiplied by, this portion will be 0, multiplied by, and at time 0, this will be cosine of 0 is 1, so it will be C2. Then plus at time 0, sine of 0 will be 0. So this will be our initial current, which is equal to 0. So we are going to have 8c1 minus 6c2 equal to 0. And we already found the value for C2, which is 1, 5. So 8C1 is equal to 6 divided by 5 is equal to 6 times 156 divided by 5. So our C1 will be equal to 6 divided by 40. So this will be equal to 3 divided by 20. So our C1 is 3 divided by 20. I hope I haven't made any mistake. So now we have the value for our C1 is equal to 3 over 20. So if we plug those values here, we are going to have, this will be our C1 will be 3 over 20, and our C2 will be 1 over 5. So this is our charge, and here we are going to have let's go ahead, simplify these. We can go ahead and factor out e to power minus 60. So here we are going to have 8c1 cosine of 8t minus 8c2 sine of 8t plus minus 6 multiply that inside there, so minus 6 c1 sine of 8t minus 6 c2 cosine of 8t plus 2 sine of 10t. So here we are going to have e to power minus 6t multiplied by cosine of 8t, 8c1 cosine of 8t. So let's go ahead and plug those values in there for c1 and c2. So 8c1 means means 24 divided by 20 cosine of AT minus 8C2 minus 8 over 5 sine of AT minus 60, so that will be 18 divided by 20 sine of 80 minus 6 divided by 5 cosine of 80 plus 2 sine of 20. So we can go ahead and simplify this further. We are going to have 24 over 20 is the same as 12 over 10 is the same as 6 over 5. So we are going to have 6 over 5 here, 8 over 5, 18 over 20 is the same as 9 over 10. So we are going to have 9 over 10 here and 6 over 5. So let's go ahead and so we have 6 over 5 and minus 6 over 5. So these two will cancel out, cosine 80. So we are going to have 8 over 5 and 9 over 10. So 8 over 5 plus 9 over 10 is equal to 10 is equal to 16 plus 9, which is equal to 25 over 10, which is equal to 5 over 2. 5 over 2. So we are going to have our I will be equal to e to power minus 6t minus e to power minus 60 multiplied by e to power minus 60 multiplied by minus 5 over 2 sine of 80 plus 2 sine of 20. So this is the value for our current. I hope I have not made a mistake. If I do, I will change the video. But I hope you liked it. Thanks.